3, 2.
I was already recording. All right, so see, this is for seniors. We are reviewing factoring skills so that we can do more complicated things. I drew a line after 5 and 6. That's because this top portion all goes together. All right, so on the top part of these, we only have a couple of terms, but you could use this for something with more terms. What I'm seeing on all of these is that there are common factors. So on number 1, I see 3a squared plus 3a. They both have 3. They both have a. So what I could do on this is go 3 times a and expand 3a squared and put it times 3 or plus 3 times a. And see that both terms have a 3 in common, and they both have at least one a. So this is going to be called the greatest common factor. So the greatest common factor for this one is 3a, or the greatest common monomial, sometimes they call it that. That goes on the outside of your parentheses, and then I have a plus, and I need something over here, a number, so I add times 1, so I have something to put in there that I can multiply by 3a. I'm okay.
Everybody's saying they're freezing, but the heaters are all working fine.
I don't know.
It is cold.
Really? You guys are just cold.
Okay, so factoring is just the inverse of distribution. So if I distributed this back out, I would get 3a squared plus 3a. It is factored completely if we take out everything we can, and there's nothing left in here in common to take out. All right, if we look at number 2, b cubed is b times b times b. B squared is b times b. So both terms have a couple of b's. So when we take that out, that's going to be b squared, and what's left is b minus, there's nothing there. When there's nothing there, you put a times 1. You have to have something for that term inside the parentheses to make the distribution work if you were to check. All right, on number 3, it gets a little bit more complicated because I have a 6 and a 24, and I want to think about greatest common factor for 6 and 24. 6, it goes into 24. So I'm going to write it 6 and then n, and then I'm going to write 24 as 6 times 4. And then n and n. So if both of these have a greatest common factor of 6, we make sure we write it with the 6, and then we take out as many n's as we can, which would be an n squared. So my greatest common factor, if you will, is 6n squared, and that's what we're taking out. And then what's left is n plus 4. Okay. Moving along to number 4, we have 4 and 28. 4 does go into 28, so I'm going to go 4 n plus 4 times 7 n for n cubed. I'm going to take a 4 out of both terms, and I'm going to take n cubed out of both terms, and so my greatest common factor is 4n cubed. And sometimes they'll call it greatest monomial factor, same thing.
That's rude.
It is just whatever book you're using. So we have 4n cubed, and then what's left over, what we did not underline, is n plus 7. So you want to be neat with the underlining. Okay, you guys are going to talk me through 5 and 6.
And then we're done?
And then we're doing the rest of this.
The
But
GCF is 6r squared.
okay, so 6r squared. And then what's left in the parentheses?
R plus 6.
R plus 6. So if we go back and look, it's 6r plus 6 times 6r. So we made sure we wrote both of them with the greatest common factor. Take out an r squared, so that looks right. And then one more before we change gears a little bit. So I have 2 and 8. So 2 goes into both of those. 2 and n. 2 times 4 and n. So I'm going to take a 2 and an n out of both terms. So 2n is the greatest common factor. N plus 4 is what's left over when we take that out. It's kind of like dividing, except that it doesn't actually go away. It's just sort of setting it to the side. And we're going to use this to do some fraction stuff later. so we can cancel some things. We're going to use this to solve some really big polynomial equations. So anyway. So I'm going to switch gears a little bit. You could look for common factors with anything. That should be the first thing you always look for if you're factoring. But sometimes they're just not there. So if you look at 7 through 14, I now have on some of them 3 terms, some of them 2. But if I look at all 3, these 2 have x's, but that one doesn't. So I can't take an x out. They don't have numbers that I can take out of all of them except 1, which doesn't accomplish anything. We looked at, when we did factoring before, a relationship between this number and this number.
X.
And we used an x.
Oh no.
So the last number is the number that goes on top, and the middle number goes down here. So this is from your constant term, this is from your linear term that has x, and there will be no coefficient on this x up here, so that's important. So we're looking for numbers that multiply to make 4, that add to make 5.
4 and 1.
So 4 and 1 multiply to make 4 and add to make 5. So what does that have to do with factoring this? Well, this is one that we're actually going to reverse FOIL. So you have x and x, everything's positive, so it'd be x plus 4 and x plus 1, even though I just wrote a 4. And that's the answer that we just got from doing this number puzzle that we worked on a lot a while back. Okay, if we look at number 8, negative 35 is going to go on the top, so we're multiplying to get negative 35. Now if I'm multiplying to get a negative, that tells me one number is negative and one's positive, so sometimes I'll put that there to remind myself.
-7.
And then when I add them, I get negative 2.
-7 and +5.
Negative 7 and positive 5. So I multiply them, I get negative 35. I add them, I get negative 2. So when you have a negative and a positive, when you add them, you're really thinking subtraction because it's the difference between the two. So my letter on this is M. You do have to use whatever letter they give you. And then we have -7 because we came up with -7 and +5. And if you were to FOIL this back out, you get this up here. And we've proven this in a previous lesson, that this works. Okay? Going on to number 9, we're going to multiply to get 32 and add to get negative 12. So I know it's going to be a negative and a negative.
-8 and -4. Right.
Yes. So we have x's as our variable. They're both negative, so -8 and -4 are in there. Okay, so if we look at number 10, we are multiplying to get negative 63 and adding to get positive 2. So you're actually thinking of numbers that multiply to make 63 that have a difference of 2.
9 and -7.
So positive 9, negative 7. I'm using n for my variables, so n plus 9 and n minus 7. We have a couple, well actually these are special and these are special, but I'm going to use the same method for all of them because you're going to have a lot of things to remember. So on number 11, we're multiplying to get 16 and adding to get negative 4. I'm sorry, negative 8, which I just gave away the answer, negative 4, because my brain... Yeah, so anyway, what's special about this is you get a minus 4 and a minus 4, which means it's a minus 4 squared. They call this a perfect square
Cool.
trinomial. Yep, it's just one of those things you got to remember all the stuff you've ever done, and I'm reviewing it. If you were in a bigger school, they probably wouldn't review this. They'd just jump into how you use it in a lesson. And in college, they skip the factoring stuff completely. They're just like, oh, I factored this, and this is what I got. And you're sitting there going, what just happened? So I'm reviewing because I feel like we're not going to remember all of this from
You're right.
when we did it before. All right, so here, we're multiplying to get 1, so that leaves our options pretty limited.
Is it 1?
It's 1 and 1. And we've got k this time, so k plus 1 k plus 1, so that would be k plus 1 squared. My answer key, we'll always write those as squared. So those are considered special. We use those a lot, actually, or we will use those a lot when we get into our conic sections unit with circles and ellipses. You know, you can look forward to that. And then 13 and 14 are special because the middle term is missing. We just have the n squared term and the constant term. So we're going to think of it as we're multiplying to get -9 and adding to get 0.
0, yeah.
Because that term's missing. So that means we need opposites. So -3 and +3 are what we're going to get for that. So n plus 3 and n minus 3 will accomplish that. Same thing over here. We're multiplying to get -25, but that middle term's missing, so we're adding to get 0. So -5 and +5. So I'll have
a special name?
yes, this is called a difference of squares.
Okay.
So these are called a difference of squares. Basically because it's something squared minus a square number.
Right.
And you can also have a coefficient on those, but we'll deal with that later. All right, so here's some scary looking things at the bottom where we've mixed up a bunch of stuff. The first thing you always look for is, can I take anything out of all the terms? So I would take my calculator and just see if 68 and 288 divide by 4. I legitimately don't remember because I forgot to open last year's notebook, so let's find out. I know that they divide by 2.
It's 17 and 72.
Okay, so I'm going to write this as just 4xxx minus 4 times 17xx plus 4 times 72 and x. So I can take a 4 out of every term, and I can take 1x out of every term. So that's going to be my greatest common factor is 4x. And then we look at what we're left with. I'm left with x times x, so that's x squared, minus, I've got 17 and x, and then plus 72. So what's inside here now looks like these. So we have to do that too. So now we're multiplying to get 72 and adding to get -17.
I don't know.
So if it's positive, huh? So it'd be -8 and -9. Okay, so the 4x is still there, and we just add in those extra parentheses, x minus 8 and x minus 9, like that. So you may have to use more than one kind of factoring in the same problem. Believe it or not, this is not everything we've ever done. This is like 2 days of what we did before in one day. Maybe 3, maybe 3. Okay, so I'm looking at the next one. I can tell by these numbers that 3 goes into all of those. So I'm going to do 3n, and then 36 is 3 times 12, and I have an n. Then 96 would be 3 times 32. I can't take an n out of everything. The only thing I get to take out is a 3, which is not super satisfying, but it's okay. And then I'm left with n squared minus 12n plus 32. So now what I have is those 3 terms like we were looking at on 7 through 10 mostly. So I'm going to make my x, 32 here, -12 here. We've already factored this one. It was -8 and -4. So the 3 still sits on the outside. I'm going to have n minus 8 and n minus 4. And I'm kind of out of room, so I'm going to do 17 and 18 on the other page. I'll just recopy them. Well, one of them is different. So we're going to do them really quick just because you're going to encounter them. You'll hate it now. You might be thankful later. I can't guarantee that, but you might. All right. So on this, what can I take out of all the terms? 5. Let's see if we can just do this in our head. If I take 5x squared and I divide by 5, I get x squared. What times 5 is 60? 12, so I'll have 12x. What times 5 is 180? 180 divided by 5 is 36, so plus 36. So this looks kind of the same. What's different is how the answer is going to come out because we're multiplying to get 36, adding to get negative 12. We did this one earlier too.
Just
Negative 6.
Negative 6 and negative 6. So I have 5 and x minus 6 and x minus 6, which makes it x minus 6 squared. So I just reduced the amount of writing to 3 lines. And then I drew a little bit into the next line, but it's okay. And then number 18 is 2x squared minus 72. I'm looking at that, and I can take a 2 out of both terms, so I'm going to do that. So I'm going to have 2, and if I take a 2 out of 2x squared, I have x squared. If I take 72 and divide by 2, I get 36. So I quit writing down the underlining part, and I'm mentally dividing, except that the 2 doesn't actually go away. We've just sort of separated it. Now, x squared minus 36 is one of those with the missing middle term. You're multiplying to get, negative 36 and adding to get 0.
Negative 6 and negative
So negative 6 and positive 6. So the 2 is still there. I'll have x minus 6 and x plus 6. You cannot write that as x plus or minus 6 or with a squared because they have different signs. And I have a practice page. I'm going to stop recording.
Hey, all you guys